Hello everyone. Welcome back to our channel where we dive into the world of programming and machine learning. In today's video, we're going to explore a fascinating topic, working with Dlib for facial landmarks. If you're interested in computer vision, facial recognition, or just want to learn how to manipulate images using Python, you're in the right place. Before we dive into the code, let's briefly discuss what Dlib is. Dlib is a modern C++ toolkit containing machine learning algorithms and tools for creating complex software in C++. It includes image processing capabilities, particularly for facial landmark detection, which we will focus on in this tutorial. To get started, you'll need to install the Dlib library along with some other dependencies. Let's open our terminal for installation. If you haven't installed Dlib yet, run the following command. Great! Now that we have Dlib installed, let's move on to the next step, preparing our environment by importing the necessary libraries. Open your text editor or IDE and create a new Python file called facial_landmarks.py. In this tutorial, we will use a pre-trained facial landmark predictor model that comes with Dlib. This model allows us to detect 68 landmarks on the human face which correspond to various facial parts like the eyes, nose, and mouth. Let's load this model into our code. Make sure you download the shape_predictor_68_face_landmarks.dat file from the Dlib model's GitHub repository if you haven't done that yet. Once you have the file, place it in the same directory as your Python script. Next, let's write a function that will read an image file and return the detected facial landmarks. We'll use OpenCV to read the image and process it with Dlib. Here's how you can do this. This function takes an image path as input, reads the image, converts it to grayscale, as Dlib works better with grayscale images, and then detects faces in the image. For each detected face, it predicts the landmarks and stores them in a list. Now, we need a way to visualize these landmarks on the original image. Here we've created a function called drawForLandmarks that accepts an image and the landmarks. It will iterate over the landmark's coordinates and draw small circles on each landmark's position. Now, let's integrate these functions together in our main flow. Now we have our main function that first gets the image and landmarks, then draws the landmarks on the image, and finally displays the image using OpenCV's imshow function. To run our program, add the following lines at the end of your script. Make sure to replace your path.jpg with the actual path to your image file. Now let's run our program to see if everything is working as expected. Go ahead and execute your script. As you can see, the image is displayed with the facial landmarks placed on the respective locations on the face. This is a powerful feature of Dlib that can be applied in various scenarios including facial recognition, emotion detection, and more. But what if you want to save this annotated image instead of just displaying it? Let's add a saving feature to our code. Here we have created a simple function called saveImage that takes an image and a file name as input and saves the image using OpenCV's imWrite function. We can modify our main function to include this new feature by prompting the user for an output image file name. With this change, after running our program, an annotated image will be saved as output_image.jpg in the same directory as your script. Feel free to change output_image.jpg to something else if you'd like. Now let's discuss error handling. It's essential to handle errors in case the image path is invalid or the image cannot be opened. In this modified version of the detect_landmarks function, we handle the case when the image cannot be opened. If we encounter such an error, it raises a value error with a message indicating that the image is not accessible. This makes our code much more robust. Now let's talk about potential improvements and extensions to what we have built so far. One of the extensions you might consider is integrating this functionality into a web application where users can upload their images and you can display the detected landmarks live. You could use Flask or Django to build such applications. Another interesting extension can be real-time facial landmark detection using a webcam feed. This function captures the webcam feed in real time and draws the facial landmarks directly on the frames while the video is being displayed. You can exit the program by pressing Q. This is just one of many ideas you could explore during your projects. Before we wrap up, let's briefly summarize what we have covered today. We began by understanding what Dlib is and how it can be used for facial landmark detection. We set up our development environment, wrote functions to detect and draw facial landmarks on images, and then demonstrated how to save the annotated images. We also improved error handling and discussed possible extensions to our project like a web application and real-time detection. If you found this tutorial helpful, don't forget to give us a like, subscribe to our channel, and hit that notification bell so you never miss an update from us. If you have any questions or suggestions for future tutorials, feel free to leave a comment below. Thanks for watching, and happy coding!